All right, let's start again. So welcome to re:Invent 2024. Who's excited to be here? Come on, let's make some noise. The other session is not happening now, so we can speak loud. All right, perfect. I want to tell you something. You know that Gartner, McKinsey, and our own data in AWS shows that more than 80% of the companies around the world are currently investing in generative AI. However, only 24% of those companies are having workloads in production. And 21% of those are actually having a good foundation, a good framework that allows them to do governance and cost control. So this is a big gap. My name is Antonio Rodriguez, and along with Jati Agarwal from the Amazon Bedrock product team, we want to share with you a few ideas on how Amazon Bedrock can help you closing that gap and provide the enterprise readiness. We think that the data is very clear. If you don't have enterprise readiness, then you are not going to be able to deploy generative AI workloads in production in an effective way. So in the agenda, we're going to cover a bit of what we call enterprise readiness. And we are going to also talk about three areas that are very important for that enterprise readiness, which are the compliance and governance, cost and performance management, and the operational excellence. Finally, we are going to wrap up by talking a little bit about what is it that we call a generative AI platform. So what is the architecture looking like when we want to implement generative AI at a scale? All right, let's start with this concept of the enterprise readiness. So most of you will agree that when we talk about having generative AI in an enterprise, in a company, normally what we want is a combination of these factors. We want a solution that is able to scale gradually, right, according to our needs. So we are able to start small and then scale to a point where we can actually support potentially hundreds or thousands of use cases in production. We want to have the latest foundation models that are available in the market. And we want to make sure that those models can be used plug and play, right? So we can directly implement a new model in a very easy way without much changes in our application. We also want to have tooling that allows us to use our data for customization, and that includes RAG patterns, that includes agentic patterns as well, and of course, fine-tuning and any other type of customization that you could be using. And last but not least, you want to make sure that your data remains secure and that you have privacy in everything that you do with generative AI. Now, this becomes even more complicated, I would say, when you consider that we need to have multiple business units in our teams that are working with generative AI. Potentially, we will have dozens of product and engineering teams that are working together. And of course, we have hundreds, and in some cases, even thousands of use cases that are happening in parallel that have their own specific needs for generative AI. So in the next minutes, we are going to talk to you about three main stages that we see for deploying generative AI applications in production. The first stage is what we call the onboarding and compliance. So you can imagine this stage as how I need to make sure that I validate every model or every tool that I'm going to be using in my company, that it is according to the regulation, that it is according to the policies that I have in my company, for making sure that I can actually use those models in production, that I can actually make sure that everything is secure and protected in the way that I want. So for that, in Amazon Bedrock, we obviously offer you model choice and flexibility, which is very important. So making sure that you choose the right model for the right job. The other part, of course, is the security and compliance. It should be actually the first that we mentioned here. Make sure that everything is aligned with the regulations, making sure that everything is aligned with our own internal policies, as I said before. And last but not least, we need governance and control. This means making sure that we have very granular access at the user or group level and at the project level, depending on what we need in every case, and that we also have the cost control in our applications everywhere. Now, the second stage is typically what the application developers will do. So they go and build. For that, they need to have integration capabilities, obviously, with your own tooling, with open source frameworks, with other AWS services. They need to have features that allow them to do customization or fine-tuning accordingly by using your own data and your own data sources in the organization. And you need to either use code or low code or no code applications that allow you to develop rapidly, right? So accelerate this development process that you have in a company. So this week you are going to be learning about a lot of new things that we are actually launching for helping in this stage, in this middle area. We have a lot of exciting things coming, so stay tuned, especially tomorrow and the day after tomorrow. Now the last part is moving workloads to production, right? So actually deploying workloads in production. So for that, we need to make sure that whenever we deploy, it's actually able to scale, that gives us the flexibility to scale automatically, that it also comes with cost control or cost management considered, and that it has performance monitoring and observability, which is very important. And finally, that it is reliable and has everything that is necessary for supporting from a support point of view. Now, obviously, we are here because we're going to tell you that Amazon Bedrock simplifies all of that journey, right? So right now, Amazon Bedrock offers you model choice from the main foundation model providers that we have in the market. We also offer you toolings for doing customization with your own data and integration, as I said before, with open source, but also with your own systems and with other services, even with third parties where relevant. And we also offer you now cost and performance management so that you can easily control what your users are doing with generative AI. And finally, but more important than everything else, we have security and governance in place so that you don't have to worry about this heavy lifting of controlling what the users and the teams are doing. In this session, we're going to focus especially on the first and last stage of those three that we showed before. As I said before, you have a lot of content for that middle section in the other sections of the reInvent this year. Now, for talking about how Bedrock can specifically help you on this task, Jarek is going to tell us a little bit about this enterprise readiness.
Thank you, Antonio. Hello, everyone. So we all know building generative AI applications which are enterprise ready is extremely challenging. It's transformative, but also comes with a lot of considerations. And that's where Amazon Bedrock comes into the picture and helps ease this journey. So Amazon Bedrock, as we all know, is a fully managed service. It offers a choice of foundation models from leading AI labs. It allows you to customize foundation models with the help of techniques such as RAG and fine-tuning. And additionally, you can also build agents to execute certain tasks. You can evaluate your foundation models, and all of this can be done in a secure, private fashion without having to learn about the underlying infrastructure. So one of the very important pillars to building an enterprise-ready generative AI application is compliance and governance. Now, under compliance and governance, Amazon Bedrock helps in three different aspects. First of all, it presents the EOLA of the legal agreement that the customer enters into with the providers for them to have a very clear understanding of what the agreement holds, what is the terms and condition for using the particular LLM, and this can be done at the time of onboarding itself. The second part is Amazon Bedrock is already in scope for compliance certifications. We'll dive deeper into it in the following slides. And thirdly, Amazon Bedrock provides you the ability to implement advanced safeguards with the help of guardrails. Now let's look at a short demo of the onboarding journey on the Bedrock console. As you can see over here on the left panel, you have the model access. So you go to model access to gain access to all the models listed over there. So if this is the first time you're going to model Bedrock console, you must first select all the models that you need access for. And you are granted access within minutes. So along with the list of models, you can see the access status and the EOLA associated with that model. So you can click on the EOLA and read through the agreement. Now moving on to the next demo, over here you have the providers on the left panel. You click on the providers, you see all the providers listed on the console. Each provider also has model cards. The model cards basically tells you what is that particular model being used for, and you can use that model based on your use case. In the model card, you will see a link to EOLA again, which you can go through, and make sure that you go through all of this EOLA before you apply for access for any of the models. Now coming to compliance certifications. So Amazon Bedrock is in scope for multiple compliance standards. So for example, ISO CSA star, and it is GDPR and HIPAA compliant. It is also an authorized FedRAMP High service in GovCloud region. Now let's talk more about the data security on Amazon Bedrock, right? So with Amazon Bedrock, you can have control over the data that you use to customize these foundation models. This data is encrypted end-to-end, whether it's in transit or at rest. And this can be done with the help of AWS KMS servers. Additionally, on Amazon Bedrock, we do not use this data to improve any of the foundation models. Further, we do not send this data to the providers. One other thing that you can do is you can also establish connectivity between your Amazon VPC to your Amazon Bedrock with the help of a private link, and that prevents you exposure to the internet. Now coming to Amazon Bedrock guardrails. Our customers have told us that they want to get rid of harmful contents, toxic contents, and irrelevant contents when working with LLMs. They also want to safeguard sensitive data and remove it from the responses. Additionally, they want to filter hallucinations. Amazon Bedrock guardrails helps with all of these aspects. Now, one of the major USPs of guardrails is that it helps you implement safeguards which is customized to your particular business use case. Today, it helps to block as much as 85% more harmful content than protection natively provided by some FMs on Amazon Bedrock today. Guardrails has support for knowledge bases, agents, foundation models, and not just foundation models on Bedrock, for third-party models and also self-hosted models. Now moving to the next pillar, which is cost and performance management. Cost and performance management is crucial for building generative AI applications, as it helps you set usage limits, billing alerts, and it also helps you develop an application which is much more resilient and highly available. So there are three ways in which Bedrock platform helps you achieve this. So the first one is cost tagging, the second one is cross-region routing, and the third one is inference modes. Let's deep dive into each of these options. Customers have told us that as they adopt generative AI technology in their business, and they have this technology across all of their projects and business units, it becomes very difficult for them to control and track cost. And not just that, it's very difficult for them to allocate cost for their particular business unit. So how does Amazon Bedrock help over here? The cost tagging and management option in Amazon Bedrock, first of all, tags all of the resources that are generated in the platform. So once you tag those resources, and you can have multiple tags associated to a particular resource, and once you have tagged those resources, you can also set alarms and notifications. You can set a threshold, and based on if a value exceeds the threshold, you can also take action on that. So now moving on to tagging resources in Amazon Bedrock. So until now, we've had tagging resources for most of the Amazon Bedrock resources. So for example, batch inference jobs, agents, custom models, provision throughput, knowledge bases, and prompt flows. So we did not have the capability to tag on-demand invocations, but now we do so. And this can be done with the help of inference profiles. And shortly, we will learn more about what inference profiles is. So we have a demo on inference profiles and how cost tagging works with it. So this particular demo with inference profiles will help you create a cost tagging with the inference profile resource. And then once you have the cost tagging set up, you will be able to run Converse APIs with it. And once you have done it, you can go to the console and see how the costs, all the costs associated with that particular resource and tag. Okay, so let's get started with it. So as you can see, there is create inference profile API, which takes model on as the parameter, tags, and profile name. So once you have the model on as the parameter in place, you have the tags in the key value pair format. So you have the tag set up, and now you can create the inference profile. Right, and you can see the status of this inference profile is active. So whenever you're creating an inference profile, it returns an on, which is a unique identifier for the resource. Now you can use the get API to get all the information for the inference profile you just created. Additionally, you can also use the list inference profile API to list all the inference profiles that you created for your account. Now moving on to using our Converse APIs. I don't know how many of you have used it. If you have used Converse APIs, please raise your hand. Okay, nice. All right, so we are going to use Converse APIs to run a prompt on the LLM. Right, so it takes the inference profile on as one of the parameters. As you can see that we are running the API and it's generating a response. All right, in terms of tags, you have list tags, which lists all of the tags associated with a particular inference profile. And then finally, you have delete inference profile to delete the ARN. Okay, now moving on to the console experience. Over here, the tags that you have created for a particular business unit, you will be able to see what was the cost incurred for that business unit, what was the original budget set for that particular business unit, and how are you faring against that budget. So you have the usage type set, the service type set, and then you look for your tag. So project was the tag and Bedrock. So you select all of that and you see the relevant information for that particular tag on the screen. Right, so once you go to budgets, you will be able to see that the original budget set for this particular business unit was $10. And right now, the threshold is in OK state because we have not used up the $10. So you can set up these limits. You can say that you want 80% of this usage as the limit, right? And once you have set up that limit, you can take action based on that. You can revoke all access to the model once you have reached that particular threshold. So these are the things that you can do with Amazon Bedrock to control cost for your entire organization. And also please note that when you are tracking and allocating costs, it can be done in a model agnostic fashion. So you can see the overall AI spend for your organization. Now moving on to the Amazon Bedrock inference consumption options. So Amazon Bedrock inference mode is extremely important for you to manage your cost and the performance of your application. And based on your unique generative AI use case, you can decide which one to use, or you can use a combination of these. So first of all, let's talk about batch inference. So batch inference, it processes prompts in batch to get responses for model evaluation, experimentation, and offline processing. So this particular batch inference is available at 50% lower cost than on-demand inference mode. That is because the SLA for this is 24 hours. So if you have a workload which is not time sensitive, please go with batch inference. And then we have the on-demand pay-as-you-go option. And over here, we do not have any commitment period associated with it. What you have here is you get best latency with an uptime SLA of 99.9%. Apart from this, please note that we execute quotas for this particular on-demand mode. So these quotas are minute-level quotas, so requests per minute and tokens per minute. And if you are looking for guaranteed throughput, then opt for provision throughput. Provision throughput helps you meet your application's performance requirements. So you reserve this throughput 24/7 in tokens per minute, or input tokens per minute, or output tokens per minute. And you have a flexible commitment period of 1 month or 6 months. There is also an option of no commit period, wherein you are charged at hourly rates. So if you go the no commit route, you will be charged hourly rates. But if you are invested in long-term commitment periods, then you will get a discount on that. It's great for production workloads or inference on custom models. So custom models works really well with provision throughput. Now moving on to the cross-region inference feature. So as mentioned earlier, on-demand executes, it enforces certain quotas, right? The minute-level quotas. So in order to make sure that your app is continuously performing, you want to make sure that any burst or spiky traffic is being taken care of. And this can be done with the help of cross-region inference. The cross-region inference also works with inference profile, the example that I shared earlier. Over here, all the regions associated with an inference profile, the request from the source region gets routed to all of these regions. And it makes sure that the request gets served in any one of the regions. This helps make sure that your application is resilient and highly available. So some of the things to note over here is that when you're using cross-region inference, you can use up to double the amount of quotas. Wherein in case of in-region regular on-demand invocations, you can only use the applied quota to your account. So, and in terms of pricing, whenever you're requesting using inference profile to run a request, then the pricing is based on the source region instead of the other routed destination regions. All right. Now moving on to operational excellence, which is the third most important pillar to building an enterprise-ready generative AI applications. Now under operation excellence, we have two parts, automation and observability. First, it's very important to understand why operation excellence is important. It helps you build applications to improve productivity, and it reduces cost over time. So let's deep dive into each of these aspects. Now, prompt engineering is one of the most cost-effective way to work with LLMs. So when you are running prompts on LLMs, you want to make sure that the prompts are optimized enough for the LLMs to generate desired responses. So Amazon Bedrock provides several features in order to make prompt engineering easier. So one of the things that it provides is prompt templates. These are predefined templates for common use cases such as summarization, classification, question and answers. Additionally, it also provides this whole prompt management system where one can build the prompt, it can save that prompt and use it in other workflows, which saves time. It can build versions of this prompt and then test each of these versions, and based on the outcome of this test, decide to use any one of them in their application. It further also helps in monitoring post-deployment. So now let's understand with an example how this prompt management works. So you have the prompt management option on the console on the left panel. So once you're creating a prompt, you enter the name and description, and you see this console pop up. So over here, you can enter the full-fledged prompt text and make sure that you can also use variables along with it. So now with this, you can change the variables wherever you want based on your different use case. Additionally, you can add some more context to the prompt so that it helps the LLM give a more relevant answers. Once you have added all the variable values, you can run the prompt on the right panel, and you will see the output soon. You can save and version this prompt that you just built. So it is as easy as this to get started with prompt engineering on Amazon Bedrock. Now, once you have built your prompt, the next step is to include it in your application. But more often than not, an application is much more complex, and it consists of multiple prompts. And not just prompts, it consists of other components such as knowledge bases, agents, and guardrails, and so on. So that's where this flow, Amazon Bedrock flows, comes into picture, because one needs to orchestrate all of these components together and build a workflow. So let's see how flows helps with this entire process. So you create a flow, you enter the name and description of the flow, and once you have done that, you see a blank canvas over here, which this is a very straightforward drag and drop interface that is provided to the customers. You drag and drop nodes from the left panel, and it could be anything. It could be another prompt, another knowledge base node, or a guardrail node, and so on. So in this example, what we are trying to do is we have a prompt, and we have a condition that if the outcome of the prompt has a particular keyword in it, then it's going to route to knowledge bases component, or else it's going to route to the other prompt. So basically, if you have, in this example, if the question or the prompt is asking about a data for your own company, you will look into your own knowledge base data and then retrieve the data from there. But if it is a prompt which is about any other company, then it's going to use a general LLM prompt response. So now with Bedrock flows, what you can do is it helps you, first of all, give you a very serverless experience. So you do not have to write elaborate code. You do not have to host your code on any of the computes. You don't have to buy compute. It's just everything is abstracted for you. All you have to do is use this drag and drop model. And you can also have the facility to version it, test it, and deploy it. And all of this can be done with the help of SDK APIs as well. Now moving on to observability. A lot of the customers have talked to us about observability challenges with their generative AI applications. So primary challenges that they talk about with observability is collecting metrics for multiple accounts and applications. They find it difficult to gather and parse invocation logs and then use this raw data to convert that into insights and metrics. Now this prevents them to take useful decisions if they do not have the right insights for their particular application. So this is where Amazon Bedrock helps them solve all of these issues. So Amazon Bedrock has an integration with CloudWatch. And I'm sure you must be familiar with CloudWatch because it's also integrated with other AWS services. So CloudWatch processes data and converts that into real-time metric. It also helps you graph these metrics. Additionally, you can set alarms. You can set notifications based on certain thresholds. And if in any case your thresholds get exceeded, you will receive alarms. So this is a snapshot of a comprehensive dashboard from CloudWatch. Now, additionally, apart from the observability capability that is being offered by CloudWatch, we have also built a custom solution. This is not part of Amazon Bedrock yet. So this custom solution, if I have to start from the beginning at a high level, user inputs a prompt to the generative AI application, which generates a response. And this generative AI application consists of multiple components, right? So for each of these components, we want to be able to get data, analyze the data, and generate useful insights and metrics, and use that to make decision on improving these components. So this entire process is what is supported in this new custom solution. This custom solution has support for model invocation, for model Amazon Bedrock knowledge bases, agents, and guardrails. Please note that this custom solution is available in Python and Node.js. Additionally, it helps you capture prompts, outputs, and metadata, custom metadata tags, and also track metrics such as trace latency, logging latency, and total request time. Let's see a dashboard of this particular solution over here. We have taken an example for RAG observability. And as you can see here, this is a very comprehensive dashboard for this particular use case. So you have the high-level dashboard and also a deep dive version of that particular dashboard. So these are the solutions Amazon Bedrock offers in order to make your journey easier to build an enterprise-ready generative AI applications. And now I would like to hand it over to Antonio, who's going to talk about moving to AI platform with Amazon Bedrock.
Thank you, Yari. So yeah, you have seen a lot of great features, and as you know, we are going at the speed of generative AI. So just yesterday, we released a few more features on evaluation, right? So now we also have RAG evaluation as a built-in feature in Amazon Bedrock already in the evaluation pane. You can find it, and also we have LLM as a judge. So I recommend you checking that out. Another feature that we didn't mention before that is also available is automatic prompt optimization, right? So actually you can go to the prompt management console that we saw before, and you have a button that says optimize, right? So you can start from a base prompt that you input for any use case. You can actually click on optimize, and then immediately it will give you an optimized version of that prompt, taking into account obviously the best practices of the model provider. So in example, imagine that you are optimizing for Claude 3.5, Sonnet, or Haiku. So it will take that into account for giving you a better version of that prompt, for making sure that the quality of the outputs are better, right? So that is already available in the platform. In this case, prompt optimization is in public preview of now. But with all of those features, one thing that we have to think about is, all right, how do we put all of this together, right? How do we actually build this platform at a scale? So we can think about different approaches that we see customers implementing for using generative AI at a scale. And one of the common approaches that we see, and probably if you are starting with a few use cases or starting with a few prototypes, everybody starts there, which is the centralized approach, right? So we normally have a single AWS account or a single environment where we are actually working at. And then we could start with one team, 2 teams. Eventually we will have 10 teams, 15 teams working together in the same account. Which has a lot of advantages from a governance point of view. First of all, you will have consistent governance, policies, access control. You will have unified security for everybody. You will have easy cost management in the sense that everything is happening on the same APIs and so on. You also have a standard process, let's say, for everybody. But it also has many challenges in the sense of how do I adapt for giving autonomy for each one of the teams that is working here? What happens if I have a marketing team that wants to use a specific model and I don't want to give access to that model to an engineering or a business or a sales team that is also working on a different use case? What happens if I want to encourage innovation and some of the teams want to start using a new feature that was released, but I don't want to expose that feature to the rest of the teams just yet? What happens if one of the teams wants to tailor solutions? In example, they want to use fine-tuning and they want to have a custom model in Bedrock. And you don't want to allow this to happen for everybody across the board. Or what happens if you want to have a very granular quota management, right? So instead of having a single quota for everybody on using a free-for-all on these models, what happens if I actually want to be more specific and assign quotas per team, per project, or per user even, right? So in that case, normally we see that the other hand is, I started with free for all, you give freedom to everybody, and then immediately I start to say, okay, I need to control, I need to have some trade-offs here, right? So we have the decentralized approach for encouraging innovation, decentralized approach for encouraging central governance. Well, what if I tell you that 21% of the customers who are actually implementing generative AI in production are following mostly what we call the hybrid approach, which is having a bit of the best of both worlds, right? So we have in one hand that enhanced security, cost optimization, comprehensive monitoring, and all the advantages that we have with the centralized approach. But at the same time, we actually have the ability to give flexibility and scalability to the teams, allow for them to have customization, allow for have granular quota management, and so on and so forth. So with that in mind, we could be picturing an architecture that looks a bit like this, right? So, and by the way, this is just a common denominator, but obviously for each one of your companies, this is going to look a bit different, right? So you actually customize this to whatever it is that you have in your own requirements. But normally, what we see is that you have a central generative AI platform that we see in the right-hand side, where you are actually managing from an admin point of view. So if I'm actually the admin, the IT admin, the Center of Excellence administrator, whatever it is that you have with a governance responsibility, you can actually implement there what we call the generative AI gateway, which is this access for everybody, where you actually can control who can access to what through the APIs that you expose in your system. You also have the networking and security taken care of in that point. You onboard new foundation models. So whenever we have a new release of a model and we need to onboard that, make sure that it's compliant, that it follows the regulations, we read the ULAT, we get our security teams to approve all of those models and so on. We do it in this space. We have a centralized login, audit, and monitoring space as well. And then we have, obviously, all the cost control and access management in that platform. Finally, we have the tooling, right? So if we have shared agents, or we have set for my organization, or if I have knowledge bases that I want to have control of the vector databases that are created there, or if I want to manage the integrations with my own systems, like an example with the identity providers that I could be using, or with my own tooling, or with third party, or with my own data sources. In example, I want to connect with my documents, I want to connect with my data lake, and so on and so forth. Now, in the left-hand side, you see the spaces for the different developers, right? So here we have what we call generative AI workspaces. So in this place, you can imagine that we have different environments. In some customers, those are different AWS accounts, even, that we could be having, where they are completely having freedom in their environment to develop their applications as they want. And normally, that is a space where they actually integrate with the central platform through the gateway, right? So in that way, we can actually give that sense of the hybrid approach that we talked about before. If we try to map this with features in Amazon Bedrock, it will look a bit like this. So in the left-hand side, you have obviously the Amazon Bedrock playground. So that allows you to experiment quickly, or allows your users, right? So imagine that you have here again your marketing team, your sales team, your engineering team, and so on and so forth. They are actually using the playgrounds for experimenting with the models to see which model is the one that is giving them the best answer that they want, and so on and so forth. Then they are actually building on the prompt lifecycle using prompt management. In example, they develop their prompts for the use cases, they optimize the prompts, as we said before, they iteate on it, and so on and so forth. They could be even implementing flows. In example, if they want to define logics of multi-agent multi-agent workloads that they could have, they could use flows programmatic or in a drag and drop way, as we saw before, and they define all of the logic for their application. Now, in the right-hand side, in the central platform, what we can see is actually the components that we use for that central generative AI platform. So in the access, we have the Amazon Bedrock APIs, like Converse API, Invoke Model APIs, and all the inference profiles that we could be creating, the batch inference in the case that we are using batch use cases, and so on and so forth. And then we have all the features for tooling, like Amazon Bedrock agents, knowledge bases, guardrails, all the foundation models that we have onboarded, the custom models that we could be allowing, and so on and so forth. Finally, we have all the logging and security that Bedrock provides you out of the box, so that you don't have to worry about that heavy lifting of setting up all the governance and the foundation layers of your generative AI applications. And by the way, with regards to the cost management, this is the place probably where you are actually implementing that central cost tagging that allows you to map projects from the different teams, map the usage of each one of the teams in their generative AI workspaces to a specific tags, so that you can actually watch that in Cost Explorer, in the billing console, or that you can, as we saw before, set up budgets, so that you can, in example, send notifications or implement actions to do throttling, to remove model access, or even just to let the teams know that they are over budget and things like that. So with all of that, let's try to do a summary. So we started by saying that there is an important gap in the industry, right? So we said more than 80% of the enterprises around the world are investing in generative AI, with the big problem that only 24% are actually going to production successfully. So how do we close that gap? Well, we have seen, and you can use this as a playbook, or at least a few ideas for building your own playbook on how to go to production in an enterprise-ready way. First of all, keep into account that we have 3 phases in the journey. The first one is onboarding, second one, development of the applications, and the third one, the actual deployment. you have to implement the proper compliance and governance. Keep into account, and this is a real fact, we are seeing that the model life cycle in the generative AI industry right now is less than 6 months. It means that right now, a model that is considered legacy is having less than 6 months of life. This is crazy, right? So if we come from the machine learning world, where we used to have models like, I don't know, Flan, or these kind of models that were there for years, and people were still using it in production, now we are in a completely new age, where the speed is completely different. We need to make sure that we have a very well-oiled pipeline for model approvals and onboarding. That has to be automated. You cannot have manual verification of models and, let's say, all the bureaucracy involved in onboarding new models. You have to find methods to automate that. So for helping on that, obviously rely on the model access that Amazon Bedrock provides you, and all the help that you can get from the AWS teams for setting up those model approval pipelines. The second thing is ensure that you have an efficient cost and performance management. So for that, you have to make sure that you give the flexibility to the users, but all of them have a regulated access, and obviously they can access to the resources that they actually need to. The other thing is you can rely now in features like the cost tagging through the use of application inference profiles, in example, so that you can be very granular on the consumption that all your teams are doing. And you have to have a good mix, let's say, of the consumption options that we defined before. So having the on-demand provision throughput and more that are coming soon in the right way, so we are making sure that we always keep the cost optimized for our workloads. In terms of operational excellence, we saw an example with prompt engineering on how to implement automation. But I would say automation has to be a must for you in everything that you do with your platform. And that also includes all the tooling that you have available in Amazon Bedrock. As you see, we release more and more features for helping you on that journey, and we will hear more about that in the coming days. And the other thing that is very important, or I would say critical, is having a strong observability. Think on the use case that I have multiple app users using a chatbot, in example, that I have with a rack setup or an agent that I'm using, and so on and so forth. It's very important that you are able to trace that the same user is actually going through different elements of your application and is interacting with the same application in different times of the day, and so on and so forth. That is needed for troubleshooting, that is needed for cost control, that is needed for quality of service, and that is needed, obviously, for cost control. So the way to do that is by implementing a healthy observability tooling into place. So rely on Amazon Bedrock with all the features that we have for monitoring, for logging and tracing. Rely on guardrails as well. The Amazon Bedrock guardrails right now offers you, as we saw, a lot of features that help you protecting your applications, but also to help protecting your data, that you are not exposing any sensitive data, any private data that you don't want to, and so on and so forth. And finally, choose the right architecture so that you make sure that you can scale. It's true that we all start, as I said before, simple is the obvious and most recommended way to start experimenting with generative AI. But at the end, you have to think that if you are part of a big organization that could eventually get to having tens, potentially hundreds or thousands of use cases in production, you have to make sure that you are not creating barriers in your architecture. So make sure that you keep in mind that the most mature customers that we have are going towards those ideas that we showed before on the hybrid approach or the hybrid paradigm. Now with that, we want to leave you with a few resources to learn more. Here you have a list of blog posts, articles, and even you have a custom solution on GitHub also for implementing what we call Access Gateway with Amazon Bedrock, so that you can even open access to third-party model providers or to other services like Amazon SageMaker and so on and so forth. So I recommend you checking those resources on. You have the links there to try to make it shorter and simpler for you. Finally, you also have in our AWS machine learning blog more information about every one of the features that we have talked about here. And of course, contact your account teams if you want to learn more about any of those topics. So with that, thank you very much. You have our contact details over there. And thanks for your attention. And I hope that you have a great week in Rainband.